Hi guys, today we will cover the topic mechanical properties of materials. Mechanical properties describe how material reacts to external forces. So we are talking about tension, force, compression, bending, or torsion. This will help us to decide which material is best for a specific engineering application. For instance, steel is good on tensile force. So that's why we said steel belongs to ductile materials and concrete is very bad on tension but very good in compression. For instance, concrete has a very huge compressive strength. But in comparison to compression strength, tensile strength is only 1/10 of the compressive strength of concrete. So this will help us to decide which material is the best. These are two specimens. The first one is subjected to tensile force. The second one is subjected to a compression force. And what we can notice when specimen is subjected to a tension force, we will have elongation length and we will have elongation stress. If specimen is subjected to compression force, then we will have wedge length and we will have a wedged width. So stress strain diagram will help us the most when a specimen is subjected to tensile force. And what is the stress strain diagram? It is a graph that shows how a material behaves under gradually increasing load. So on x-axis we will have a strain, so that means how much the material stretches, and on y-axis we will have a stress, how much force per unit area is applied. So this one is example of ductile sigma-epsilon diagram, and what we can notice, we have some particular points. Firstly, we have proportional limit, then we will have a yield stress, yielding, then we have a strain, hardening, ultimate stress, and fracture stress. So this will be the critical status for strength specification. So what we can explain here, when we have the proportional limit, that is a point, the first point which you can notice, this is the point up to which stress and strain are directly proportional. So we are saying that in this region, that is elastic region, and only in that region Hooke's law applies. So that means that stress is equal modulus of elasticity, which is again property of the material, and we have times epsilon, which is our strain. So the material behaves elastically, which means if you remove the load here, it will return to its original shape, and we have the linear region on the graph, and beyond this point, nonlinear behavior starts. So think of it as the last stop before things get real with deformation. So then we have yield point, which is point B or a next point on the graph. This is when the material starts to permanently deform, also called yielding. Even a small increase in stress causes a large increase in strain, so the material won't return to its original shape when unloaded. This is the start of plastic deformation. In ductile materials like steel, the yield point is very visible, often shown as a sharp drop or plateau. In brittle materials, it may not be well defined. You might go straight from elastic to fracture. Then we have ultimate stress, which is also known as ultimate tensile strength. That is a maximum stress, or it is the highest point on the stress strain curve, the maximum stress the material can withstand before necking starts and failure becomes imminent. So what happens at ultimate stress? The material has already passed the yield point. It's in the plastic zone. So it stretches significantly, but still holds the load. After this point, necking begins, a local reduction in cross-section. Stress appears to decrease, but only because the area is shrinking rapidly. For you, very important, even though the load drops after this point, failure is coming soon. Why is ultimate stress important? It tells you the maximum capacity of the material under tension, critical for material selection, so for failure analysis and design of ductile members, which means design of steel, then used in limit state design, especially when accounting for plastic redistribution. In ductile materials, the ultimate stress is well above the yield point. In brittle materials, for instance, aluminum, cast iron, there may be no clear difference between yield and ultimate. They fracture soon after elastic limit. So the difference between ductile and brittle. Brittle material will fail without any previous notice. But ductile material, you will have several stages before the fracture point. And at the end, we have a fracture stress. So fracture stress is the stress at which a material completely breaks apart. It's the last point on the stress-strain curve. After all the stretching, yielding, and necking, the material can no longer take any load and it fails. What you need to know here, strength parameters. You need to know modulus of elasticity or Hooke's law, that sigma or stress is equal Young's modulus of elasticity times strain. Then modulus of resistance or modulus of resilience, so that is the area below the elastic part of the curve. So take care about this part. Usually I am giving something from the stress sigma-epsilon diagram on the exam. And we have a modulus of toughness, which measures the entire area under the stress-strain diagram. So this will be the main parameters of sigma-epsilon diagram. With this, I will close this section. So maybe I will do some examples in the next video. Thank you for your attention.